But taking away heat is the same thing as decreasing temperature.
I don't understand like the shifting left and right.
It just means that there's either more of stuff on this side, on the left side, or more stuff on the right side. So in this case, after you've drawn all the little arrows, it becomes pretty clear. Where there's more up arrows, that's going to be increasing. Where there's down arrows, yes. So this is now shifting right, meaning that there's more of the products. Okay, yes?
Well, like, on a question in the book, it
yes.
said, it said, will the following reaction give you more or less products if you add more A to the reaction? I'm like, can you go over like one of those if you add more?
Right, if we add more. So let's do that. We'll just do it with this equation up here. Excuse me. You can have this back. Let's say that we add more. I don't know.
H2H2. No. It just says.
What do you want to add?
MG.
You want more MG?
Yeah.
OMG. We got more MG. We're going to add more. We add more of this stuff. So if you add more of that stuff, what's it going to do to this?
It goes down.
It's going to decrease because more of this is combining with this to make more of the product. So over here, are these going to be more?
Yes.
Yeah, you better believe it.
All
It's
of
going to
them?
go up, boom, boom, boom. It's going to heat up. Yeah. Question.
Can you say, okay, say you decrease the magnesium in the reactant side,
Yeah.
and then it would be opposite, but then on like on the product side, would the magnesium decrease, like just like that?
Just like the heat example.
Does it shift to the right?
Yeah. So in this case, yes, it shifts to the right. So there's more products. We can run through that real quick afterwards. So you're asking a different question from this, though. I'm just wondering if you have any questions about this.
Oh, I'm asking a different question.
Yeah.
Oh, never mind.
It's okay. Yeah.
Well, in this problem, so does that mean that there are more products or less products?
What do you think?
More?
Why?
Well, because they go up,
Right.
so there is more.
Yeah.
But in this one, it like
Sure.
so like
No one's on the screen.
Will the following reaction give you more or less products?
Don't touch
if
me,
you
Ted.
add more A to the reactions? So if you add more A, that's the Yeah. Okay. Just clarifying it. Okay. Hold on a second. You had a question?
Okay, so can you go over the thing where there's the graph and there's those lines?
Yes, let's go through that. And before that, let's talk about Emma's. And you have another question about this?
Yeah.
Okay.
So let's say I were
You have 4
to
minutes.
like take away anything in the like if you take away something in the reactant on the reaction side, that means like the other part of it goes up and then the products go down.
Yeah.
And then but if you were to take away, let's say you weren't to take away heat, you were to take away like this.
Let's take away the MG, because that was Emma's question. Let's take away this. Take away this right here.
No, wait.
I think
I didn't say take away. I said less. Is it the same thing?
same thing.
Okay.
You take it away, there's less of it. So
More HCl.
there is going to be more or less of HCl.
More. And then the other side would be less.
Yeah.
And over here,
Less.
these would all decrease.
Less.
Okay. So then let's say you were to take away like H2.
Okay,
Does that mean like
let's do it. Let's take away
does that
H2.
mean that everything else does that mean like the heat and the MgCl2 goes up and then and so you take away something on the product side, everything else goes up and the reactions go down.
Yeah.
And then if you were to add something on the if you add something on the reactant side,
Yeah.
it goes down, everything on that side goes down,
And
but
the product side
the
goes up.
products go up. But what? And then
You've gone over every single scenario.
did I say if you add something on the
Yeah. Add something on this side, these will go down, and that'll go up. Okay?
Okay, but I don't mind. What if you don't? Okay, so if we're taking away that magnesium on the reaction side, then
Yeah.
how is it on the product side?
We just
No,
went over
I
this.
don't get it.
Why is it less over there? Because there's less magnesium combining with this HCl then. So there will be less of these products over here.
But,
We can talk about it one-on-one if you really, if it.
but I just thought I thought we're taking it all.
We don't
Not the whole
have
thing.
time.
Let's talk about one problem now that you wanted to talk about before. I'm sorry we didn't get to the
Which
graph of the endothermic, exothermic graph, Anastasia, but you can look at your notes if you have questions about that. We can talk about that. The mole train, and it's actually a quiz problem, that 5.2 quiz problem. Here it is. I'll tell you what it is.
There's only 4 scenarios, right, for that?
I'm not sure. There, yeah. So the question says how many grams of H2S? I always use H2S for some reason right now. How many grams? Oh, it's because it's easy to calculate. How many grams of H2S do you need to add to, let's say, what does it say? To 2.78 liters to have 4.8 molar solution. Okay, there it is. How many grams of this do you need to add to 2.78 liters to have a 4.8 molar solution? Okay, for this, we start off with our molar. Molarity is moles over liters. Okay, so here is our molarity, it's 4.8, and our liters is 2.7. We don't know what our moles are yet. The moles of H2S.
Oh.
We don't know what that is. This is just like the problem we did yesterday. So you need to find the moles right here. So we'll multiply 2.7 times 4.8, and we get, quickly,
13.344.
13.344. That's right. And that's moles of H2S. H2S. Now you have to convert this thing into grams. And so you say 1 mole of H2S, and then you have to figure out what the molar mass is of H2S. The molar mass of H2S is?
Wait, time out.
4.0808.
Right, that's right. 048? Something like that?
0808.
0808. 08. 0808. Then, when you multiply this, the moles will drop off, and then we're left with grams. So the final unit is going to be grams. So this whole thing equals in 454.7. And is that with correct sig figs?
Yeah.
No.
774.
Now with correct sig figs,
No.
we've got only 2 sig figs. So it could be 450 grams. That works. You could also do 4.5 times 10 to the 2
Wait,
grams.
Because
Because there's 2 right here.
Wait, is that the kind of like mole train problem?
Can it be
Yes.
5 times 10?
Also,
There's like more simpler.
there could be a good question with this. There could be a different one where I ask you to convert molecules of stuff into moles. Okay?
Right, necessary.
That's what we didn't cover.
Which formulas are you going to give us on the test?
I'm going to give you molarity as moles over liters.
Yeah,
I'm going to give you that equilibrium equation where it's like K and Q. K equals big A.
Oh, this one,
little
yeah.
a, and then we also have molar midlane. Alright, let's do it.
Could we write
There's a little bit more, and that's related to like mole conversions. We didn't quite get through all the mole conversions. We spent a lot of time on endo-exo.
Could we have written like 45 times 10 here?
45 times 10, that's still the right answer.
Yeah.